Okay, so choice of methods. The choice of methods is how many methods you have, and of course we have, generally speaking, two types. If specific to Java, of course we have constructors and we have getters and setters, and we have methods that represent certain behaviors, certain operations, certain actions, certain things that the object can fulfill. So choice of methods varies, right? It really depends. Programmer will decide what methods should exist. Some methods will have long lists of parameters, shorter lists of parameters. Some methods could be split into into a combination of smaller methods and so forth. So choice of methods is, I think, my criteria for a size of a method would be that as long as it fits on one screen, it's okay. But as I begin the need for scrolling up and down, I immediately, it's sort of like an instant signal to me is that maybe it's time to think about splitting that method into multiple methods and have another method that essentially makes a call to these methods. All right, so placement is essentially where do you place your methods and where do you place your data attributes, right? Because how do you connect this address? Do you connect this address to a property? Do you connect this address to the parcel of land? Do you connect this address to property owner? And there could be a combination of those as well, right? So in other words, where do you keep everything, and who gets what in terms of the attributes and methods is where we talk about the placement of both methods and attributes, is how accurate it is, how effective it is, contributes to the quality after all. Concurrency, sometimes things can be done in parallel. So concurrency semantics contribute to the quality. There could be all kinds of problems with multi-threaded applications, essentially an application that starts multiple threads. For instance, if you research on the web, oftentimes you'll find that there are certain problems, for instance, in web browsers, where certain plugins degrade the performance of web browsers. For example, you could play an animation inside a certain type of web browser and experience the unresponsiveness or slowness or improper sound playback and things like that. Why? Because the impact is the concurrency. Perhaps these animations, which are complicated things in themselves, do something in the background or not do something in the background to run concurrently in such way that the user has the right experience, the expected experience. So it depends, of course, on the operating system type and the browser type and the plugin type and the type of animation that is being played. There's so many different things. But concurrency, multi-threading, can have some serious impact on quality after all. Granularity, that's where we say how big or how small our modules are. And that's not specifically objects only, right? Sometimes you can have files that are way too big, and maybe you should have more than one file for certain things, right? So granularity refers to the size of both classes, how many attributes, how detailed those attributes are, again, how many methods do you have, and anything that can be measured in terms of how many is the aspect of granularity. And granularity, I think it's desirable is to keep it on the smaller side, right? You don't want that every single file that you have is like 1,000 lines long, which still can be okay for certain problem domains, but again, if you have a single file with 3,000 lines in it, perhaps maybe you should have multiple files. So it's not just about classes, it's also about anything that you keep modular. Also, in Java you have packages, so you can use multiple packages and separate package for your user interface, for your business objects, for your database, for your other third-party libraries of useful classes that you may be using. So most likely packages will give you also another level of granularity, and in an application with thousands of classes, it's probably not a good idea to keep all of the classes under one package. You want to hold them in different subdirectories that correspond to these packages. Choice of relationships with other classes. Remember, aggregation, composition, dependency, association, inheritance for hierarchical relationships. All of this also impacts the quality because it simply depends what kind of structure do you choose for your design. And of course, choice of implementation, right? If you decide to write your own sorting algorithm, whereas already there's a library method that does a sorting of your array elements, is probably not a good choice and therefore will simply be degrading the quality of your application. So in other words, implementation, I think improvement of implementation is always or almost always when you re-examine what you do with respect to the libraries that you use, okay? And in some environments, instead of writing loops, you could be instead using vector math and matrix math, okay? Because that's just more natural for that hardware rather than doing your math with individual elements of your arrays and the collections, right? So choice of implementation is largely, I think, dependent on the type of hardware that you have, but more often the type of software libraries that you use, okay? So more criteria for the quality of abstraction: coupling, how tightly related your objects are, how independent they are. Cohesion means, again, cohesion is a criteria that essentially, in the first place, you have to decide this GPS location attribute belongs to which class, if it's not a separate class, and say, okay, maybe a land parcel will accommodate it. That's cohesion. That's somehow you took an idea of the parcel of land and your GPS location, and they came so close to one another so that one became an attribute of another, right? So that's essentially the result of some sort of cohesion, which can be a very short decision, or it could take longer time because you may stay undecided for a while, but eventually from your experience you decide to put things together, right? So then, property owner and the property, they have being associated like this, therefore they're relatively close. There is an indicator that they're relatively close, property owner and the property. Okay, so cohesion means it's just basically a set of decisions you make to say these pieces, these components of my application are more closely related and should stay together as a group and perhaps should form a separate package in my Java application, for instance, right, compared to others which should not be so close and should be much more independent. Sufficiency means that, of course, you have enough operations, you have enough data attributes. Completeness is that again, completeness. I think sufficiency is more about the data attributes, and completeness is more about the operations. Because completeness is where you say, okay, now I have everything, and that object looks really good. It really looks pretty complete in terms of what capabilities are built into it. The primitiveness right? Primitiveness is always something that you want to watch out for. You don't want to over-engineer things, right? So again, with this example of zip code, you can fantasize about, all kinds of aspects about the zip code, but if the most appropriate way of storing and representing your zip code is a string, you should go with that, right? Because like I said, if you really develop the need for more sophisticated zip code, you can always move on from that primitive type to more complicated type. But relatively speaking, primitiveness actually translates to, I think, the size of your data attributes, right? The size of your data attributes is really the less data attributes you have, clearly the less primitive your object is, and that's a good idea. But of course, you can also look from at the primitiveness at the perspective of how complicated the public methods are. So that sometimes there's so many different methods, and there's maybe so many different rules to use these methods, which would entail some sort of protocol. That it becomes hard to use the object, and that's probably compromising the primitiveness of that, and therefore reducing the quality of that class design, right? So we have looked at this big picture, but now we have a list of more detail, like for different types of these abstractions. We're trying to talk about individual criteria, right? So coupling really measures the intermodule dependence. It can be between the files, if this is application written in C, or it can be dependence between the objects, if this is object-oriented environment. And so it represents the strength of the forces external to the module, pulling it towards other modules, right? Pulling means simply that basically the changes in one part of the system are all of a sudden making significant impact in the other, and that's what we can draw on the UML diagram as dependence relationship. But overall, this is coupling. How close things are related. So for our use, these forces are logical as opposed to physical. Again, it's like I said, you can have separate objects, but they can be very closely related. By the way, in C++ environment, usually this is an example of friendship. Sometimes you can declare certain classes to be friends of other classes, so they can go and directly access private members of other classes, breaking the rules of encapsulation. And that would immediately, anything, you can search a C++ application for friend keyword, and every instance of that friend keyword would contribute to the dependencies between different classes in different modules. Quality of abstraction measures strength of intramodule relationships within the module, represents the strength of forces internal to the module, and largely a class, right? Not just a physical file, but a class. Right, and so these forces are logical as opposed to physical. So we can, again, in our sample here, perhaps again in terms of quality of abstraction, again, perhaps. For instance, we mentioned that you can have property sale, right, which will probably refer to a property owner or maybe multiple property owners sometimes, right? But you also can tie it to closing. You can tie it to all kinds of preconditions that you have to have, and all of this within a single sale has to be implemented properly so that we have these criteria that all the logical requirements are in place, as opposed to physical requirements. Physical requirements are distributed between the closing event, the property owner over there, and so forth. Right. So that is the aspect. Sufficiency, abstraction, they're all kind of related, right? Because you can almost see the connection between the prior slide and this slide. But sufficiency in abstraction is essentially that we do specify all necessary characteristics of an object. In other words, all attributes are there. For example, we can use the elevator bank to manage the elevators. So obviously, number one priority in responsibility for the elevator bank is to hold on the collection of elevators, right? But at the same time, the characteristics are, the number of these elevators, the types of these elevators sometimes, and essentially we're talking about this sufficiency of do we have enough information that can be properly utilized by the application. So, and of course, it will be all specific to your problem, right? Because if you move the same bank of elevators to a different problem domain, to a slightly different application, all of a sudden there could be lots of characteristics that no longer apply in this new world, right? So you can just drop them, and you will be sufficient with less information. So that is sufficiency. Completeness is really the usefulness of all of it, right? So the usefulness can be compromised by both the lack of, but also the overextension of data attributes. So there, right? So there needs to be the right balance, but the right balance can be measured by its completeness, that we have exactly as much as necessary, but not more, because we really don't want to over-engineer any of that. Primitiveness. Okay, I mean, again, this is all iterative because it's all very much interconnected between those various pieces. Essentially, a property of an abstraction that provides only those services which cannot be obtained by sequences of other services. Let me give you this type of consideration. For example, this parcel of land, which describes a physical location of that land. It has GPS, coordinates, world coordinates. It also may be specifying other parameters. Some of the parcels of land can be pretty irregular, like this, right? So what do you do to describe the actual physical geometrical state, right? You can use some kind of polygon to describe it, but it can go even crazier. That it may be basically like there could be some kind of right of way that crosses it here, and which splits it into actually two parcels, but you want to record it in your application as a single entity and so forth. So this can be crazy. So you may just basically ask your engineer or someone to go out and do the accurate measurements and put a paragraph describing it with all of the details, and do their own land survey to calculate the area. And basically it may have taken them like 6 hours, right, to do the surveillance and do all the computation and record it and place it on the plan and so forth, right? So that you don't want this to be some kind of computable by simply height and width or something like that, right? So you really want to record the area like that. you want to record the area to store a specific value in it immediately, right? As you basically save it in your database. On the other hand, if you have a different application where you have shapes, right? We have shapes, and these shapes can be, triangle, rectangle, and circle, and trapezoid, and other things, right? If you have these types of things, you can instead make your area computable, right? So instead you want to, record the parameters of each shape and compute the area instead of store it as a separate attribute, right? So that is the consideration for the primitiveness, right? So what do I do? Simply store the area or make it computable? Well, again, it depends on your application problem domain. So another interpretation for this is that class should provide to its clients only the operations requiring the access to its implementation, its state, right? So again, area could be an attribute. However, you probably don't want to expose it. You want to provide a method, a getter and setter perhaps, that would store that information and do what's internally appropriate for that implementation, right? But again, the primitiveness, it depends on what do you do to do your computations and what do you do to store and how do you store your data. Placement, we mentioned placement. In this case, sometimes placement of attributes is more obvious than placement of methods, right? Because methods really represent interactions between the classes. Because one object starts calling another object, and it does this by invoking a certain method. So that interaction is represented by that, the caller and the callee and the method that's being called. So the placement of methods in the class should reflect the distribution of responsibility among these classes. What this really means is that each class in your system should have clear responsibilities. If you don't have clear understanding of what this class is responsible for in this software, you probably are open to mistakes of placing methods of in the wrong class, right? So it's just something that you need to be aware of. And priorly mentioned cohesion, applicability, obviously, and other criteria to suggest that the methods are placed properly is that how reusable the concept becomes, right? So if I placed all of my methods associated with the property or property owner or the title for the property, if they're properly placed, this thing can become reusable, right? Because I can take a lot of these components and, for example, reuse them writing some sort of like a property insurance application, right? Because all of these can be very effectively used. All of these concepts I have so far can be most certainly used in the insurance business for real estate. Not necessarily managing the real estate or recording the sales or deeds or issuing those titles or certificates and so forth. It can also be used in other areas. So clearly, reusability is a great factor to look at. Like basically, look at this class that I'm trying to describe and put together. How successful it could be used someplace else. And that should be an interesting criteria. And implementation, again, which kind of falls into the dependency area as well. How independent the implementation is this just, how, in other words, if I begin to take this concept through different use case scenarios, if I begin to take this concept and pretend that I'm trying to use it in a different problem, in different application, how much implementation do I need to change, right? Sometimes, if there are many changes, it could indicate that your method is misplaced. Maybe it doesn't belong here. Maybe it belongs in a different class, right? So that would be an idea regarding the placement of methods.